homework 2-3, we start talking about variability in data. When we were talking about mean, mode, and median, we were talking about the center of data. That's kind of, all of these deal with the center of data. What I mean by that, if I gave you a bunch of numbers, a bunch of test grades, let's say, if I did the mean or the median, and the mode gets lumped into there too, it should tell you something about the center of the data. Now, variation, as we start to study that, that's going to talk about how spread out our data is. So let's say you're that student that makes 100 on every test. Okay, there's very little variation, or actually no variation, in your grades. Okay, but let's say, for instance, you're that person that can make a couple of hundreds, forget to study, the material gets hard, and these are our grades. Well, then you've got some variation there, okay? And so we can put some numbers attached to this variation. One of the first ones we talk about when we talk about variation, the easiest type of variation is called range. And that's simply the difference between our biggest number and our smallest number in our data. Okay, so if I'm the person that makes 100 all the time, my range is 0, because those numbers, my big and small numbers are the same. 100 minus 100 is 0. However, here, if I'm following this category down here, my highest number, and then subtract the lowest number, I'd have a range of 50. Okay, so it tells me how spread out those data are. So in these first questions, they give me the salaries of employees at certain companies, and they ask me some questions about them. So here, first question is, based on the information above, which company's salaries have the most variability? So variability, the keyword's variability, that means I'm going to be looking at the range, because range is a type of variability. So if I look at the ranges of these companies, which one's got the biggest range? That's going to be the most variability that they have. So it looks like this one's got the biggest number here with range. So I'm going to say company C has the most variability in their salaries. Next question, based on the information above, which company has the highest salaries on average? Average, we're talking about some kind of measure of center here. So I'm gonna be thinking of the mean is a type of average, and I want to know which one's got the highest average, which one of these numbers is the highest numbers. Boom. Looks like company B. All right, so variability is dealing with range, and when we talk about average, we tend to talk about mean there. So that's all you got to do on that first problem. Let's move on to the next one. I'm going to come back to that. Let's talk about this one. All right, so it says Miss Washington has 25 students. How many books, ask her 25 students, how many books each had read last summer? The smallest response was 9 books. The largest was 15 books. The table gives the mean, the median, the range, and the IQR, the interquartile range. We'll talk more about that later, of the data. So over here in this chart right here, I have the data from this little survey that this teacher gave. The mean, think about, that's really what you think of as average, right? We took all of her 25 students and took their responses, added them up, and divided by 25, this is the number we come out with. The median, so if we took all these 25 students' responses, put them in order, and went to the middle number, this is the number we would have come up with. That's the median. The range, we put these 25 students, the number of books they read in order. We take the biggest number minus the smallest number, and we get 6. The IQR, that's where the middle 50% of the data is. So we'll talk more about this in detail later, but really the 50% of the data is going to just have a spread of 2, and I'll show you what that looks like here down as we get to the bottom of this problem. Okay, so first question, select the best description of the spread of the data, okay? So here in this first one, it says, we can tell by the range that the difference between the largest and smallest number of books read is 6. Well, the range is 6. The largest number of books read is 15. The smallest is 9. That's the difference of 6. So this is a pretty good statement. I'm going to check it, but I want to double check these other ones just to make sure I'm not missing something. Here it says, we can tell by the median that the difference between the largest and smallest number of books is well. No, the median doesn't tell us the difference. It just tells us what the middle number is. All right, and this last one, we can tell by the number of students in the class that the difference between the largest, the number of students in the class doesn't tell us the difference between the smallest and largest number of books read. So I was right in picking this one to start with. All right, part B of this. Select the best description of center of data. Now, center, again, when we talk about center, you're thinking about mean or median, really. Okay, it says the average number of books read was about 25, which is the number of students in the class. No, so I'm talking mean or median, right? That's my average. I should be looking for something with 12 in it. The average number of books was about 2 to 6 based on the IQR in the range. No, the average number of books was about 12 because it has mean. It's based on the mean and the median. Okay, there you go. Oh, that's my wife sneezing, sorry. Select the graph with the shape that best fits the data. Let's think about, so, bless you. So, number of books read, and remember, the smallest number of books read was 9. The largest was 15, based on what we read up here. So, boom, 9 and 15 was the smallest number, okay? The center of our data, the mean and the median, should be 12. See how that's 12's right there in the center? See, this doesn't even have, over here, it doesn't even have 12 in the problem. Just the last thing on this problem, remember me talking to you about the IQR up here, the interquartile range. See how the middle of this data goes from 11 to 13, that difference of 2 there. So that majority of that middle data, the middle 50% of the data really is falling between 11 and 13, which is just a difference of 2. That's where that 2 is coming from right there. But again, we'll talk more about that later. All right, good luck with those. What do we got next here? All right, we got a stem and leaf, actually a double stem and leaf plot. And it says the stem and leaf displays below gives the test scores for students in Professor Carter's 10 a.m. class and his 11 a.m. advertising classes. There's 17 students in the 10 a.m. There are 18 students in the 11 a.m. Use the display to answer the questions that follow. Okay, so it says, what is the range of the 2 classes? All right, so here we go, 10 a.m. right here. We're just looking at, see, what are these again? These are, gives the test scores. Okay, so like in this 10 o'clock class, this 4 represents a 40, and that means, right there means somebody made a 41. Somebody made a 48. somebody made a 51, a 53, a 55, a 55, a 57, a 59, like that, okay? So in this 10 a.m. class, the highest grade was an 87. The lowest grade was a 41. That's going to give me my range. On the 11 a.m. class, the highest grade, somebody made a 95. And the lowest grade, again, was at 41. And that's going to give me my range. Okay? Which class had the higher median score? So we got to find, now these are in order for us, so that's nice. The thing you got to remember is there are, well, it said there were 17 in here, there are 18 students over here. All right, so 17 being an odd number, that it will have a middle number to it. So that means 17, that middle number is going to be the 9th number. Okay, I'll have 8 on one side, 8 on the other, and that 9th number will be my median. So if I count to the 9th number, so 1, 2, excuse me, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means a 61 is the median number here. Now on this side, since I've got 18, I'm not going to have a middle number. I'll divide that by 2. I'll need to take the 9th and the 10th number and average them. So let's find where that is. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9, there's 10. Well, it's nice. They're the same thing. There's 67. Both of them are 67. So when I average them together, I'll get 67. Okay? So which class has the higher median score? Boom. That would be the 11 o'clock class. And you might have been able to tell that by looking at this data. Maybe not. I don't know. I'll definitely count those out. Which class had more scores in the 90s? Is that right? Yeah, 90s. Whether 11 a.m. did, right? Because they had 1. So there we go. That's just looking at a double stem and leaf, being able to interpret that double stem and leaf. All right, I think we got one more page here. Save the best for last. Standard deviation. Okay? If you need to get up and do a little exercise, do it, because we are going to be doing some standard deviation using this formula right here. That's my sigma symbol, summation symbol. All right, so we need to make sure you understand what certain things mean, okay? So this is this summation symbol. We're just going to be adding some things together, okay? And what we're going to be adding is what follows here in these parentheses. Now, X is just representing our data points, these 5 data points that I'm underlining right here, okay? Those are our X's. So we're going to be adding up those values after we've subtracted the mean of those values. This symbol right here, this will be a quiz question at some point, is the mean, okay? Actually, the mean of those, yeah, just the mean, okay? So that is your mean, your sample mean. This value here, whoops, sorry about that. That N down here is the sample size. So N equals sample size. In our case, what is the size of this sample? It's equal to 5. Okay, so we're going to be dividing by 5. But the first thing you have to do when you do a standard deviation problem is figure out what is the mean. Okay, so you are going to add those numbers up, and divide by 5 and come up with the mean. All right, so I add all these up. That's going to give me 180 divided by 5. 180 divided by 5 is 36. Okay, so my mean on this data is 36. So what I've got to do now is I've got to add up each data point, subtract 36 from it, and then I'm going to square it. So I'm going to add all that up and then divide by 5. And then take the square root of it. Man. All right, so first things first. I got 42 minus 36 squared. I got 41 minus 36 squared. Got 27 minus 36 squared. 29 minus 36 squared. And 41 minus 36 squared. So that's each, that is each x value. Those are my x values, the data points. And in each case, I subtracted from that the mean, which in our case was 36. Okay, so I'm subtracting that. Now notice some of those will be negative, some of these will be positive when I do that subtraction, but I'm gonna square everything, okay? I square everything, and that's gonna make everything positive. All right, so I square all that stuff, and then add it up, then divide by our sample size, which in our case is 5. And then the final thing I do after I've done all that is I take the square root of everything, okay? Because we squared everything to start with to make it positive. Now we undo that really with the square root. And that leaves me with my standard deviation. I'm going to calculate that real quick. Okay, and I get, when I do that, 6.57 when I round it to 2 decimal places. Now, so this is the standard deviation for this entire population. Now notice this is entire population because it's going to be a little different down here when we talk about a sample down here. But the entire population has a standard deviation of 6.57. As we go on, we're going to talk more about what that number means. But right now, you've just got to be able to come up with the standard deviation for a set of numbers. Okay, so population standard deviation uses this formula right here. All right, you will not have to memorize this formula. You'll always have this formula with you, but you will need to know how to use it. All right, the bottom problem down here deals with sample standard deviation. Now remember, there's sample and then there's population. I'm going to go ahead and tell you, when you're doing this on your test or your quiz, these little names aren't going to pop up here, so you don't know if it's a population standard deviation or a sample standard deviation problem unless you read and pay attention to it. Okay, it's going to say that in the problem. So down here it says, the following are distances traveled to the workplace by 6 employees of a certain computer company. Find the standard deviation of this sample of distances. So if you go back and look up here, it says, assuming that these ages were an entire population, okay? So, you just gotta pay attention to the detail there. All right, so the difference here is the formula we're gonna be using. It's very similar, it's just one little difference. So, the formula for sample standard deviation, there's my sigma symbol. There's my X for the data points. There's my mean of all the data points. And then there's N, the sample size. But for a sample, when I'm finding the standard deviation of a sample, I always use the formula n minus 1 on the bottom. So in this case, I'm going to be dividing by our sample size minus 1. Our sample size in this case will be 6 because there's 6 data points. So this is going to be 6 minus 1 down here underneath. Okay? So what would we do to find this? We would, first of all, we've got to find the mean first. All right, so we add all those numbers up and divide by 6. Get a mean of 21. All right, so then I'm going to do 36 minus 21 squared, 31 minus 21 squared, 1 minus 21 squared, 40 minus 21 squared, 9 minus 21 squared, and 9 minus 21 squared. So I want to do all that, add all those together, and then I'm going to get my number, and I will divide by n minus 1, which we've already said would be 6 minus 1, which is just going to be 5 when I plug it in my calculator. And then the last thing I'll do, once I get that answer, I'll take the square root of that. All right, and I'm going to do that real quick and see what I get. All right, and I'm coming up with 16.58 when I round it to 2 decimal places. So our standard deviation for this sample is 16.58. That's way bigger, or a good bit bigger than what we had up here. But look at the numbers. You know, look at these numbers and how spread out they are. The range on that from 1 being the smallest to 40 being the biggest. You know, these are really spread out. There's a lot of variability among those. That's why this standard deviation is bigger than this standard deviation up here. These numbers up here in this problems weren't that spread out. You know, 29 being the smallest, 42 being the biggest. There's not as excuse me, there's not as much spread there. That's the difference. All right, so this is going to be, you're going to have to be able to calculate a standard deviation by hand. Okay. Again, I'll give you the formulas. I'm not going to tell you which one's population, and I'm not going to tell you which one's sample. You got to know that. So this is our sample one. And you use the n minus 1. And this is for the population up here. But you'll have them, you just got to know how to use them, okay? And you're going to have to do this by hand. So be prepared for that. And yeah, all right. Good luck with these problems. Let me know if you need some help.